taking, remember we said that we take stoic of chemicals and represent them in several units, okay? So when we are taking stock, we can take stock in molarity, which I've explained already, or in concentration, or in mole per dm cube, concentration in mole per dm cube. We can also take stock of any chemical in form of molality, okay? Molality is simply the number of mole of the solute that can dissolve in a given mass of a solvent in kilogram. Somebody will ask, solvents, how can we measure? We can measure the solvent, not just the volume, we can also measure the mass, okay? We can measure the mass of a solvent with a chemical balance, okay? We can measure it with there is a method we can use to measure those masses, okay? To give us the answer in kilogram, not just the volume, right? So the mass of the solvent in kg will be divided the number of mole of the solute. So remember that the mole, of course, you know that the unit for this molality will definitely be what? Mole per kilogram. Okay? Or you can write it this way. Some of you are just familiar with this. Okay? So both of them are the same thing, right? So these are the units of what? Molality. So how do we know which one is the solute, which one is the solvent? From the question, you can be able to tell. Remember that the solute and the solvent are two different things. The solute is what you are trying to dissolve in the solvent. For example, if I have sugar and I have water, and I'm dissolving sugar in water, the sugar is the solute, the water is the solvent. Don't be mistaken also, we can also have a liquid solute and a liquid solvent, right? For example, I'm trying to dissolve your liquid milk in water. If you put liquid milk, your not your powdered milk, if you are dissolving a liquid milk in water, that liquid milk is the solute, the water is the solvent. Also, you can dissolve in the lab. There are some universal solvents, there are some solvents that we can dissolve, used to dissolve some other solutes. For example, you can dissolve toluene in benzene, okay? It's still, both of them are in liquid state, but one is the solute, one is the solvent, okay? So dissolving a solute in a solvent does not necessarily mean that the solute is in solid state, okay? Solutes can also be in liquid form and can be dissolved in a solvent. You can dissolve a liquid in a liquid. Let me put it that way. You can dissolve a liquid in a liquid, and one of the liquid will act as the solute, and one of the other liquid will act as the what? Solvent. So, but when this thing comes in calculation, you should be able to, if it comes in a question, because most students, the problem they have is how to differentiate which one is solute, which one is what? Solvent. Even if you cannot differentiate from just looking at these two substances, you can also differentiate by the nature of the question, how the question will come about. You will now know which one is solute, which one is what? Solvent. Take a look at the question on the board. What is the molality of a solution made by dissolving 5 grams of toluene? This is the compound toluene. Toluene is an organic compound. Look at the structure. For those of you who don't know what is toluene, toluene is something like this. Okay? So this is a conjugated system that has this. Okay? So it's the same thing with C7H8. That is, there are 6 carbons here. 1, 2, 3, 4, 5, 6. Plus this one, 7, right? And there are what? Hydrogen here, just one. Hydrogen, hydrogen, hydrogen. So total of how many hydrogen now? We have 8 hydrogens. 1, 2, 3, 4, 5. Plus this 3 here, making it what? 8. So this is the structure of toluene. So that's the molecular formula C7H8. In 224 grams of benzene. Benzene is, from the question now, can you tell me which one is the solute, which one is the solvent? You are dissolving 5 grams of this inside this. So the solute is toluene, the solvent is benzene. Okay? So very simple. So from there now, let us know, we know that molality is mole of solute over mass of solvent in kg, kilogram, right? But the mole of the solute was not given. The solute is toluene. Remember, toluene is the solute. The mass was given and the formula was given. Okay? So how do we get the mole of the solute? We know that mole of solute, which is toluene, is equal to mass over molar mass. Right? So how do we find the molar mass of toluene? C7H8 is equal to, how do you get the molar mass? 12 times 7 plus 1 times 8. So when you do 12 times 7, this should give you 7 times 2 is 14. 7 times 1 is 7 plus 1 will give you 84. So this will give you C7H8 will be equal to 84 plus what? 8. So 84 plus 8 is equal to 92. So this is the molar mass, right? In gram per mole. So we quickly get the what? The mole. So the mole of the solute. Mole of solute will be equal to, what is the mass? The mass of solute is what? 5 gram. So it's going to be 5 gram divided by 92 gram per mole. So quickly, if you divide 5 divided by 92, you will have the mole to be 0.05435. Let's take 35 mole, right? So the next thing is to get the what? Molality. Remember, you are getting the mole. The mass of the solvent was given as 224. So mass of solvent is 224 gram. Convert to kilogram. Okay? The mass must be in kilogram. So you divide by 1000, you get 0.224 kilogram. Right? So you now get the what? Molality. So remember that molality is the mole of the solute divided by the mass of the solvent in kg. So you simply have this mole divided by this mass. You have 0.05435 divided by 0.224. So when you divide that on the board, the answer becomes 0.24 mole per kilogram. Mole per kilogram. So that is the final answer. That is the final answer. So take a look at the solving. It's straightforward. What did I do? The formula. We'll find the mole by dividing the mass over the molar mass. The mass was given as 5 grams, the solute. The molar mass of the solute is C7H8. We found it. 12 times 7 plus 8. You have 92. So you divide 5 by 92, you get this, which will now be what's at the top here. The mass of the solvent, 224 in grams, but it must be in kg. So you divide by 1000, you get this. So you divide these two, you have this. So the unit, the molality of this solution is 0.24 mole per kilogram.